You bite down, and the edge of your tooth disappears. Not all at once. A grain of sand grinds between your molars. A tiny flake of enamel breaks loose. You swallow without noticing, because this has happened before. For most of human history, teeth did not remain smooth, white, and sharp for decades. They flattened, they cracked, they wore until yellow-brown dentin showed through the enamel. And yet your ancestors kept eating. How? The first answer is that a worn tooth was not automatically a useless tooth. Enamel is the hardest material in your body, but it is not indestructible. Once it is gone, your body cannot grow it back. Beneath it lies dentin, a softer living tissue that wears faster and can become painfully sensitive. That sounds like a design failure. But your mouth has several ways to delay the disaster. As the biting surface wears lower, the tooth can continue to move slightly upward from its socket. Dentists call this compensatory eruption, meaning the tooth slowly rises to preserve contact with the tooth above it. Bone around the roots also remodels, changing shape as the bite changes. Your jaw is not a fixed stone trap. It is living architecture. A 2013 study led by Anne Markvelashvili examined the jaws from Dmanisi in Georgia, where early humans lived about 1.8 million years ago. Her team showed that heavy tooth wear and remodeling around the teeth could dramatically alter the shape of a jaw during one lifetime. That matters because some differences that once looked like separate kinds of ancient humans may partly reflect age and wear. The jaw changed because the teeth changed. The body kept adjusting. Could that adjustment last forever? No, but it could buy years. Inside a living tooth, new dentin can also form along the wall of the pulp chamber, the hollow center containing nerves and blood vessels. This extra layer does not rebuild the lost crown, but it may place more material between the grinding surface and the nerve. Your tooth is being worn from the outside while defending itself from the inside. That defense works best when wear is gradual. A slow, steady loss gives the tooth time to respond. A sudden fracture can expose the nerve before any protection forms. One unlucky bite on bone or stone can still turn a useful tooth into a source of infection. Ancient food was full of unlucky bites. Wild plants could be fibrous, tough, or coated with dust. Meat might carry grit from the ground. Ash from a fire could enter food. Later, stone grinding added microscopic rock particles to flour. You were not only chewing the meal, you were chewing the landscape. Researchers study this damage through dental microwear, meaning the microscopic scratches and pits left on tooth surfaces. Those marks reveal that tooth wear came from more than food alone. Your front teeth could become tools. You might clamp a strip of hide between your incisors while scraping it with a stone flake. You might grip sinew, soften plant fibers, hold wood, or pull material tight while both hands worked. The mouth became a third hand. Virginie Volpato and her colleagues studied a Neanderthal known as Regordo 1 from France. In 2012, they reported angled scratches across the front teeth that matched repeated hand-to-mouth cutting movements, with the tooth marks also supporting the conclusion that this individual was right-handed. Picture the action. You hold a strip of hide in your teeth. Your left hand pulls it tight. Your right hand brings a sharp stone edge dangerously close to your lips. One slip could cut your face. Every successful stroke could cut your teeth. A larger 2019 study led by Kristen Kruger compared microscopic wear on the front teeth of Neanderthals and early modern humans. The researchers found no significant overall difference between the groups in these non-food uses of the teeth. Both appeared to have performed heavy clamping and grasping tasks. That means the famous image of a Neanderthal abusing the front teeth was not simply a primitive mistake. Early members of your own species did similar things. Teeth were durable equipment carried everywhere. But every tool has a working life. What happened when that life began to end? First, you changed how you bit. If one side hurt, you moved food to the other. If the front teeth were worn, the back teeth carried more of the work. If a molar cracked, you tore smaller pieces and swallowed them after less chewing. Your behavior adapted before your technology did. Then the group changed the food. Stone flakes sliced meat into thinner strips. Hammerstones crushed bones and tough seeds. Roasting softened tissue and loosened connective fibers. Pounding broke plant foods before they entered the mouth. The tool did part of the chewing outside your body. Cooking mattered even more. Heat can soften some foods, break down plant cell walls, and make animal tissue easier to pull apart. It does not make every wild food gentle, and burned grit could still damage teeth, but it can reduce the force and time needed to chew a meal. Amanda Henry, Allison Brooks, and Dolores Piperno found plant microfossils trapped in Neanderthal dental calculus from sites including Shanidar Cave and Spy Cave. Their 2011 study identified starches and other plant remains, with evidence that some plant foods had been cooked. Dental calculus is hardened plaque. It is also a tiny archaeological pantry. Those trapped particles show that ancient diets were not simply endless mouthfuls of raw meat. Plant foods were selected, processed, and sometimes heated. Each step could help a damaged mouth keep functioning. Now reconstruct the evening. Your molars are worn nearly flat. One tooth is loose. Cold water sends a bright pulse into your jaw. The hunters return with meat, but you cannot tear through the toughest strip. Do you starve beside a pile of food? Someone cuts your portion smaller. A stone crushes marrow-rich bone. A roasted root is mashed against a flat rock. Fat, soft tissue, and cooked plant matter require less grinding than dry hide or raw tendon. The group changes the texture of survival. This is where teeth stop being only a biological story. They become a social story. At Damani C. David Lordkipanidze and his colleagues described an early human skull and jaw belonging to an individual who had lost all but one tooth several years before death. This person lived roughly 1.77 million years ago, long before agriculture, metal knives, or modern care. Surviving for years after such extreme tooth loss demands an explanation. The researchers considered soft food, food preparation, and help from others. The fossil cannot tell you exactly who handed over a softened portion or whether anyone deliberately provided care. But it shows that a nearly toothless individual continued living in a dangerous environment. A mouth had failed. The whole survival system had not. Perhaps that individual selected naturally soft foods. Perhaps tools reduced meals into manageable pieces. Perhaps other people shared food that had already been processed. Most likely, survival did not depend on one solution. It depended on several small advantages stacking together. This is easy to miss when you imagine prehistory as a contest won only by the strongest body. Strength matters when you face cold, injury, and predators, but a group that can feed a person with damaged teeth preserves experience, memory, childcare, tool knowledge, and social bonds. The weak mouth may still belong to a valuable mind. Could ancient people treat the pain itself? Sometimes, in crude ways. At Cova Forada in Spain, Marina Lozano and her colleagues examined a Neanderthal upper jaw with severe wear and gum disease. They found grooves between the teeth consistent with repeated probing by a toothpick-like object. The team argued that the individual may have been trying to relieve painful irritation. Imagine pushing a sliver of wood or bone into an inflamed gap because pressure feels better than throbbing. There is no anesthetic, there is only experiment. You rinse, you probe, you avoid one side, you chew something softer. You learn which plant fiber cleans the gap and which bite sends pain into your skull. Some attempts help, some make the wound worse. A worn tooth could remain useful for a long time, but once bacteria reached deep tissue, the danger changed. An abscess could spread through the jaw and surrounding spaces. A loose tooth could fall out, leaving a healed socket, or infection could become life-threatening. There was no guaranteed rescue. So why do ancient skeletons so often show astonishing wear? Because heavy wear was often normal rather than exceptional. Your ancestors did not expect adult teeth to look new. A flattened chewing surface could still crush food. Matching wear on upper and lower teeth could preserve a workable bite as both surfaces changed together. Even exposed dentin did not always mean immediate agony. The counterintuitive twist is that less wear did not automatically create healthier mouths. As food became more processed, softer, and richer in fermentable carbohydrates, teeth often faced a different enemy. Sticky starches and sugars fed acid-producing oral bacteria, increasing the risk of cavities even while chewing surfaces wore more slowly. A smooth modern diet can spare enamel from abrasion. It can also leave decay undisturbed. Ancient humans were not protected from cavities, and some hunter-gatherer groups consumed enough starchy food to suffer serious decay. But the balance between wear and disease changed with diet, processing, and lifestyle. The old problem was often too much friction. The newer problem was often too much fuel for bacteria. Neither mouth was perfect. Survival came from flexibility. Your teeth could erupt slightly as they shortened. Bone could remodel around them. Dentin could thicken inside. Hands and stone tools could process food before chewing began. Fire could soften a meal. Other people could finish the job. That final defense may have been the most important. Because evolution did not give you replacement adult teeth. It gave you a brain able to invent tools and a social life able to distribute effort. A tooth could wear down. A group could compensate. That truth still sits behind modern life. Blenders, knives, ovens, dentists, dentures, and implants are new versions of the same ancient strategy. Move part of the work away from the failing tooth. You do not survive because every body part remains perfect. You survive because problems can be transferred into tools, knowledge, and cooperation. So you bite down, and the edge of your tooth disappears. What keeps you alive is not the tooth that vanished, but everything your ancestors built around its loss.